people trickling in. Perfect. All right, because we have a packed agenda, so we'll just kick it off right now. Awesome. Thanks everyone for joining us. Welcome to our session. My name is Julia Celeru, and I'm the co-founder of Proptech Collective. In case this is your first time joining us for an event, we are a collective of real estate professionals, technologists, entrepreneurs, and community builders that believe that technological innovation can change the built world for the better. You can always read more about how to engage with us on our website, proptechcollective.com. We've actually partnered with the Collective for Advancement of Connected Buildings, so this is CACB, to launch the Climate Change in Canada webinar series, which is focused on identifying pathways to expedite Canada's transition to net zero by coupling power, building, and transportation decarbonization at a building and community level. The CACB has a goal to provide support and development services to help with electrification-driven decarbonization as it pertains to building technologies. So we're very thankful for this partnership. We're also very thankful to all of Proptech Collective's partners for supporting our not-for-profit community. Please feel free to reach out to them to find out how they can help you accelerate your growth. So a few housekeeping rules before I pass it on to Sharmila, our lovely moderator today, to help frame our session and introduce us to the panelists. The session is being recorded, so please keep your mic and your video muted during the session. And we're looking to make the session as informative and engaging as possible. So please add in any comments or questions you may have in the chat. They will essentially go to myself or Olta, who's my co-host, and we'll be taking questions from 12:30 onwards. So there's going to be lots of time to engage and ask questions that you might have. So when you do ask these questions, please direct them to myself or Olta. And if you could, please specify which speaker the question should be directed to. So yes, without further ado, I'd love to introduce you to our moderator today, Sharmila Ravula. She's the VP of Sales and Marketing at Peak Power. So Sharmila is joining us from Silicon Valley and has over 20 years of experience in sales and marketing for behind-the-meter renewable energy technologies, including solar, energy storage, and microgrid solutions, particularly in the CNI segment. She's held executive leadership positions for companies such as Peak Power, Enact Systems, AMS, and Bosch Building Grid Technologies Group. So I'll pass off the baton now to you to take it from here.
Thank you, Julia. And thank you, Alta, for organizing this great session. Thank you, everyone, for joining Proptech Collective's webinar today on the benefits of microgrids and how these distributed energy resources that are part of these microgrids at the grid edge, as we define it, can help all energy stakeholders from the perspective of the 4Ds. And by 4Ds, I mean decarbonization, which is the increased need to reduce GHG emissions, digitalization, which is to increase the adoption of data-rich systems, decentralization, which is the increased role of distributed energy resources in the overall electrical grid, and democratization, where passive users of electricity are not converting from being just consumers to becoming producers, which is they produce energy and sell it back to the grid. So with regard to the status of the current grid infrastructure in North America, as you all know, we are facing many, many challenges which are contributing to the vulnerability of our grid. And also we are having challenges with the energy supply in North America. The increased effects of climate change, including storms, winds, fires, and floods that we see with more and more regularity across the entire North American continent and as well as the world, are having a huge impact on how electricity is being supplied and how electricity is being used and the various challenges associated with it. And also, as you all know, the grid in North America is dated, it's very old, and there are a lot of scheduled retirements of existing centralized plants, including nuclear, gas, and coal plants, which are impacting the energy supply and creating additional challenges. With the growing adoption of distributed energy, this gives us an opportunity to rethink how the grid should evolve and what the new grid would look like. And microgrids play a huge role in this. And today we will be looking at these different aspects and the innovations that microgrids can bring to the grid. From the context of 4 different companies, we have 4 great panelists here today to talk about the different aspects of microgrids, the benefits and the opportunities that microgrids can provide us. The way I would like to structure the discussion today is have each of the panelists introduce themselves and talk about different aspects of these microgrids. In the session today, we will explore the different ways microgrids are being developed and how buildings and communities are a key element of microgrids because they can offer the greatest potential to both contribute and benefit from the application of these distributed energy resources. So with that, I would like to request each of the panel members to not just introduce themselves, but also get into some detail on how they and their teams define and implement microgrids. Steve, could you kick this great session off and introduce yourself and also talk about how AMP Energy implements microgrids?
Absolutely. And thanks, Sharmila. Thanks for having me today. It's great to be with you. So as you may have just mentioned, I'm the SVP origination at AMP Energy. In fact, one of the original founders of the organization in 2009. So certainly seen a significant change over the last 12 years. And prior to that, I was in the traditional energy space, more on the gas and electricity hedging side of things. My mandate at AMP is to continue to grow out our formidable decarbonization offerings, primarily throughout North America. Just a word on AMP. So we're a 12-year-old company, as I'd mentioned. We started out and began our lives as developer, owner, operator of renewable energy infrastructure. We've done so around the world in key markets like North America, Japan, India, UK, Australia, to the tune of about 6 gigawatts. So we've seen a massive ramp up on that side of the ledger for us. In 2019, we somewhat did a pivot, moving away from not abandoning, but certainly expanding our offering more in an investment in a grid edge digital platform out of Europe. And that's really informing our business today, and specifically really allowing us to fulfill our vision around developing not just commercial microgrids, but off-grid microgrids, and we'll talk about that in a minute. In our view, we define microgrids really as a local power grid, integrating small-scale distributed energy resources, generation, loads. Generation typically for us is 100% of the time going to be renewable. That's small-scale, potentially solar or micro wind, and also typically includes some firming technology like battery storage. When we talk about how we have deployed, in fact, our last 2 projects have been microgrids. The last 2 commissioned projects have been microgrids. One in a remote community in BC, in British Columbia, for First Nations community here in Canada, and the other one for one of Canada's largest municipalities. While significantly different, obviously, in scale and scope, the objectives and the benefits have really been very similar, and we'll perhaps get a little deeper into that. The big idea for us, though, when we think about microgrids and coming from our traditional business as asset developers, is really twofold. While microgrids have significant benefits across the spectrum, there's really 2 that drives our business. One is massive acceleration of decarbonization, one, and number 2, perhaps most importantly, is how it enables the unlocking of massive flexibility in this space. And this is where it directly links and hooks up to the building side. So that's us, and that's our perspective.
Great, Steve. Thank you for that. Definitely a lot of questions, specifically on the off-grid building microgrids, and also how it differs from your grid-connected microgrids. Hopefully, we can get into the details a little later. Jerry, please go ahead.
Thank you very much. Good afternoon. Thank you for having me. My name is Jerry Yun. I'm the head of a grid innovation group at a Green Energy and Technology Center. We call the Grid Center, which is a dedicated innovation hub at Electra. So Electra, you may know, is the largest municipally owned utilities in Canada. And my role is overseeing the innovation projects and advocacy efforts supporting Electra's grid modernization and DER integration initiatives that help shape the future of energy, electricity distribution grid, and utilities' new business model in the future. In terms of the microgrids, a grid receives 100% a group of interconnected load in DERs with perhaps defined electrical boundaries that act as a single controllable entity with respect to the grid and can connect and disconnect from the grid in order to enable it to operate in both grid connected or island mode. So for our practice at Electra, back in 2014-15, we established the first microgrid. In our own office, we're connecting battery storage and solar carport and supplying the critical loads to our building as well. In 2016, August, we will have the pilot established with one of small community. It's called a Penitentiary community with 400 roughly customers, including schools and hospitals. The batteries there is really providing a resilient reliability services because the local area that have a lot of outage happening. So it's a huge benefit for supplying, providing the resiliency, reliability for that small community. And last year, we had the commercial microgrid one live with Jordan College. So it was great accomplished as well. That were helping customer to not only providing resilience, reliability, but also help them to curtail the load and achieving the bill saving as well. And today, we'll go beyond building DERs. We'll continue to do that as well, but we'll look at all DERs at our grid edge and look at how can we actively to integrate them into our grid and harnessing the DER benefit to our grid. So we are piloting with in partnership with IESO and NRCan, Natural Resource Canada, to deliver the Canada First local electricity market, where we procure DERs at our grid edge, allow customer to participate in the grid services in return for revenue or profit. So really it's a win-win solution for the DER owners, community, the grid, and society as well.
Thank you, Jerry. That's it's really interesting to see how the microgrids have evolved and how you're looking at new innovation in terms of integrating and procuring distributed energy resources and making them real grid resources through the wholesale market. Definitely a lot of questions around that. Craig, with Clean Coalition, you've been doing this work focusing on microgrids for a very long time now. Would love to hear your thoughts and your work specifically in the US.
Fantastic. My name is Craig Lewis. I'm the founder and executive director of the Clean Coalition, which is a nonprofit organization that is focused on accelerating the transition to renewable energy and a modern grid. And everything the Clean Coalition focuses on is at the local level. And for us, we define local as being within the distribution grid as opposed to the transmission grid, which transmission is rule of thumb, where you see steel power towers, that's transmission, those are transmission lines. That's part of the transmission grid. Where you see wood power poles, that's within the distribution grid. The general rule of thumb, there are exceptions, but this general rule of thumb, if you're close to where people live and work, you're usually on the distribution grid. We do work both, we facilitate projects that are both behind the meter and in front of the meter. And in terms of the way that we define microgrids, I think that Jerry and others have already, provided a really nice definition. Microgrid essentially is where you have connection, you have electrical connected generation loads and other distributed energy resources that can be coordinated together because they're electrically connected. And essentially that is a microgrid. And the Clean Coalition defines two different types of microgrids. We define solar microgrids and we define community microgrids. And for us, a solar microgrid is behind the meter. So typically would serve a single building or a single campus if the campus is all served by a single meter. The community microgrid, on the other hand, can include a bunch of solar microgrids, or you can fill in the blanks. Steve mentioned micro wind, right? So that's local wind. Clean Coalition is all about local renewables. I'm based in California. Most of the Clean Coalition's work is in California. So, most of the renewables we're going to have here in California at the local level are going to be in the form of solar. So we, tend to be, weigh a little bit heavily on the solar side, but you could fill in the blanks, right? It could be wind. It could be, wind, run a river hydro, it could be biopower, et cetera. But for us, a solar microgrid, as I said, is behind the meter assets, serving behind the meter loads, and the islanding happens at the customer meter level. The community microgrids can be comprised of a whole bunch of solar microgrids, behind the meter microgrids, but also includes front of meter assets that utilizes the existing distribution grid, so that when the broader grid goes down, you actually have grid isolation switches that island whole grid areas and have lots of customers. Potentially hundreds or even thousands of customers that are part of that community microgrid and served by that community microgrid when the grid is down. I know I'm running a little long, so I'll wrap it up here. The benefits of microgrids, whether solar microgrids or community microgrids, really come down to the trifecta of economic, environmental, and resilience. And when it comes to resilience in particular, the Clean Coalition has done a lot of work in the policy side as well around valuing resilience. We have an initiative called the VOR 123. VOR stands for Value Resilience. 123 stands for how you tier loads, right? Tier 1 loads are critical, never want those to turn off. Tier 2 loads are priority. You want to keep those on as long as you can. And Tier 3 loads are completely discretionary. If you have if you're light on solar resource for a sequence of days, you have no problem turning Tier 3 loads off until the sun comes back. It's strong, and then you can turn everything back on. We also have an initiative that's really interesting. It ties into VOR 123 that we refer to as the Resilient Energy Subscription. And this is a way to finance community microgrids. There's a lot of, we're lucky to have Jerry here, representing a utility that's being very proactive in pursuing microgrids. That's unusual, at least in the United States. Utilities really don't know what the future is going to bring, right? Having a lot of potentially open up a can of worms to a whole bunch of competition from other parties, doing microgrids. So the utility's been reluctant. But the Resilient Energy Subscription is a way to basically have people that want the resilience that a community microgrid can bring to say, yes, I'm willing to pay a fee above and beyond what my normal rate tariff is. I'll contribute to this fund, and I will get a guaranteed amount of energy delivered to me every day when the grid is down, right? And once I go above that, I might get a whole bunch more, right? Depending if the sun is shining or not. But I will at least get that much, and I can keep my Tier 1 critical loads online, for that entire day. With that, I'll pass it along.
Thank you, Craig. Fascinating to see how you're working to advocate for policy changes and also coming up with new business models. So hopefully we can capture some more details through a Q&A session. Peter, Arda Power has been looking at microgrids for a very long time. So can you talk a little bit more about how you implement microgrids at Arda and the projects that you've done with the University of Toronto?
Sure. So my name is Pete Lewis. I'm a member of the founding management team at At ARDA, my background is generally as an entrepreneur and advisor in clean technology, and also as a developer of very large-scale commercial industrial projects. And for me, ARDA was a way to combine those two interests. So we're a provider of technology, software, and control systems for DC microgrids. And what I like to tell people is that we provide a solution that makes it easier to deploy the kinds of assets that I was deploying, solar on roofs and storage, in a much more efficient manner. So what we provide is a complete solution. Again, it's software and controls based for a microgrid using a DC interconnection, and one that uses almost exclusively third-party provided commodity mass-produced hardware. So in our case, when we look at a microgrid, we look at the microgrid on a building level. So we're looking at a future where generation, oftentimes solar, and storage and loads are co-located in commercial industrial environment. And increasingly, the generation, the storage, and the loads are DC based. And so for us, the most compelling advantage of our solution is that we actually dramatically reduce hosting capacity requirements. And as you know, in California and many other places, when you start to put these assets behind to connect them to the grid, and I'll take an example that we often like to provide of, say, a 500 kilowatt solar system with 500 kilowatts of storage and 500 kilowatts of EV fast charging. That would require a grid connection of a megawatt or more. And by definition, that's often very difficult to achieve. And increasingly, utilities are less able to provide that. In our case, by connecting everything on the DC side between with a single point of interconnection to the grid, we can reduce that usually to about 1/4 of that size, 250 kilowatts or less. And the size of the interconnection is defined not by the number of assets that you have connected to the grid, but by the amount of energy that you exchange with the grid.
Thank you, Peter. Yeah, having worked in the DC microgrid space, I definitely agree with the advantages. Definitely would like to actually discuss some of the load side of things for DC microgrids a little later. And maybe in the context of the next question, you could address some of these different aspects. So we've talked about microgrids now in terms of different flavors. Building level, at the building level, you have your regular microgrids, solar microgrids as Craig defined it, DC microgrids as Peter has defined them. And you also have community level microgrids, which Jerry and Steve have spoken about. So starting with Jerry, I would like to get your perspective on some of the benefits of what you see at the community level, Jerry, of these microgrids. And also, I think one of the big challenges with microgrids that I would like to get addressed through this question here is a lot of folks assume that with microgrids, if you really want to have 24/7 resiliency, you cannot do it just with renewable energy resources. Can you talk a little bit about your perspectives on whether it is achievable just with renewable energy resources or not? From the like when we talk about resiliency benefits of microgrids.
Right. Okay. So I'm looking at our practice at Electra. The benefits are huge, reliable, sustainable, from environmental perspective, GHG reduction, cost savings, those are pretty common benefits that we can achieve by microgrid. Efficient, 24/7 operate, enable smart grid technologies, real time, it can optimizing and dispatching resources within the local area, and modular as well. The technologies, flexible, scalable. So those are the benefits that came to my mind when I look at the what we have achieved, we have done with Electra. I hope that addressed the question, though. Come back to me if you need, if this.
Sure, yes, thank you, Jerry. Yes, I think you've framed it well. You've covered a lot of the aspects, the benefits of microgrids in terms of sustainability, resiliency. Steve, I guess coming to you, how can you elaborate a little bit more about these benefits? And you said the benefits are similar in terms of your grid connected buildings, grid connected microgrids and off grid. But can you talk a little bit about the differences when you are providing the same benefits? How what is different about these different systems? First Nations microgrid versus the grid connected.
Yeah, thanks, Sharmila. Yeah, as I mentioned, I mean, there certainly are similarities. I'll contrast to just to maybe paint a picture just around what the off-grid scenario looks like for us. So we were dealing with a First Nations community that was 250 kilometers, for those who understand kilometers, from the nearest power grid. And we were dealing with, thankfully, a really forward-thinking community at the time. Now, just again, to set the scene, they were running on 2 diesel gensets, aging infrastructure that was really holding them back from economic growth and prosperity, really, at the end of the day. So when I think about the contrast between the two, and I'll go back to sort of what we did for the municipality, it really is really 3 primary platforms. One is on the direct environment side. So for this microgrid, and it's 250 kilowatts, it's modest, it's a megawatt hour of storage, has some funky controllers because you had to really integrate the diesel side and really aging infrastructure, which is what these First Nations really unfortunately have to deal with. But you know, at the end of the day, we saw somewhere like 35,000 liters of diesel displacement per year. We saw around 4,200 tons of carbon, offset. But the contrast for me for this type of off-grid microgrid is the ability to enable an economic platform, enable growth, and that was key from our standpoint. So we had, again, a community of 74 residences, but did have some commercial ops. Again, that was really hamstrung by intermittency and poor power quality, outages, and things of that nature. So, I'd say that the biggest contrast from our standpoint was, enabling that growth, enabling that prosperity, expanding the economy, expanding the refrigeration capability. They were cash crops grown there. And really, at the end of the day, a higher quality of life.
Great, thank you, Steve. Craig, coming to you. Steve spoke about some of the benefits of these microgrids from based on as they provide an economic platform for these off-grid communities. I would like you to add, I'm sure Clean Coalition is looking at these community benefits as well. But in the context of the work that you've done in California, can you talk a little bit more about, when we talk about the benefits of microgrids, are you able to provide those benefits of these microgrids with 100% renewable energy resources within the microgrid and the challenges associated with it?
Sure. Yeah, and by the way, I'm really honored to be here with this esteemed panel, and I want to be clear that the Clean Coalition, we're a nonprofit, and we facilitate these types of projects. We facilitate them to a level where you could say it's preliminary design level, and then we bring in the AMPs and the ARDAs and other solutions providers to actually do the final permit ready, finance ready projects. So Steve and Peter, and Jerry, and Sharmila as well, love to work with you all. And I do consider myself an honorary Canadian because I did my senior year of high school in Camrose, Alberta. and I worked for a year in a cement manufacturing plant in Regina, Saskatchewan, the year after high school. So I've been up in Canada for 2 years of my life and love it. Have lots of friends and family there. So anyway, with all that said, Sharmila, I'll get back to your question, which is, can a community microgrid, can microgrids, solar microgrids, community microgrids, renewables driven microgrids, can you actually get to 100% renewables? And the answer is yes. The key is to focus on tiering the loads. So not all loads are created equal. If you think about your own home, and you just you force rank the loads in your homes. Like if I do this, the number one load in my home is the refrigerator. When the grid is down, I want to make sure that my food is preserved, and that actually has life consequences, right? If the food goes out and you don't have any place else to get food, you're going to die. So to me, there are loads that are life sustaining, and a refrigerator is one of those. Next on the list for my home is internet access. Internet access means you need to have your Wi-Fi router needs to be operational, and you need some plug loads, because Wi-Fi is great, but if you don't have a charged up phone and or computer to access, right, you might as well not have your Wi-Fi router working. So right, that's kind of number two in my home. And you could just go down the list. Obviously, if you're somebody who's got medical equipment at your home, that's a tier one load, right? That cannot turn off if you want to preserve life. So the tier one loads, when you really think about it, like, are people going to die if the load goes off, or potentially die? That's the kind of the threshold for a tier one load. And tier one loads are usually a very small percentage of the overall loads. So what you have to design for when you design a microgrid is that the tier one loads will never turn off. And if you do this with a solar, in the form of a solar microgrid, you're designing for the worst sequence of weather days from a solar standpoint to make sure that those tier one loads will never go off. Well, guess what? The worst case sequence of days is a lot worse than the average day, which means on the average day, you're going to have way more energy than you need probably to cover everything, tier 1, 2, and 3 loads. Everything can stay on. So, the answer to the question is really yes. Your renewables driven microgrids can provide 24/7, 365 coverage, but you have to be smart about the way you design it, and that means tiering your loads in a way that match with kind of where the value of resilience is, right? That's why we call it VOR 1, 2, 3, value of resilience 1, 2, 3, tiering loads into three categories. I'm going to just pause there, and Sharmila, feel free to ask me to drill deeper if you want me to, but I want to give everybody else fair time too.
Absolutely, Craig. Actually, that really ties in with what I would like to ask Peter, because they look at DC microgrids and they actually look at loads and converting it to DC and improving the energy efficiency in buildings. So Peter, could you, when we talk about the benefits of DC microgrids, can you talk, I think efficiency of the buildings is not something that usually we typically think of in terms of microgrids, but DC microgrids have a huge impact on energy efficiency as well. So can you talk a little bit more about the benefits of DC microgrids from the perspective of efficiency and resiliency?
Sure. So obviously in a DC microgrid, when you're interconnecting typically DC sources and loads, so the most obvious distributed energy source is solar, which is naturally DC. Storage is naturally DC, and increasingly many loads located from electric vehicle fast charging, which is a focus of ours, to LED lighting, to electronics, are DC. And so inherently, if you are designing systems from scratch and you knew you were going to be co-locating all of those resources, you would naturally integrate them using DC. The only reason that historically they've been integrated using AC is because of people's length of experience with AC as part of the public grid, and the fact that the public grid supplies certain features on AC systems. So what ARDA is doing is to replace that in the DC side of the world. So we're able to eliminate redundant energy conversions back and forth between AC and DC, transformers. What this does is to increase energy efficiency in the building itself, and has the ability to lower costs through the elimination of unnecessary hardware. But it goes beyond that. So those are the most, I think, obvious benefits of a DC microgrid. But when you tie everything together on the DC side and have a single point of interconnect using a bidirectional inverter with the grid, then you make the burden on the grid is dramatically lower than it would be for an equivalent system that's AC interconnected. So for us, actually, that's one of the biggest selling points, is that we dramatically reduce hosting capacity. In that University of Toronto demonstration system that you referenced before, we sort of took that to the extreme. That was a lab at U of T that wanted a DC microgrid. They have solar, there's storage there are a variety of DC loads, and they had no ability whatsoever to export to the utility. There just simply wasn't any hosting capacity at all. So in that system, we have a rectifier. We're able to import energy, but we don't have any other impact on the grid. It was not necessary for us to get any kind of microgrid permits. It basically was the same as a solar system on the grid. And one other advantage beyond the hosting capacity and the energy efficiency that everyone sees is that DC microgrids, by their nature, are simpler. So with AC, you have to manage voltage, frequency, phase. They're complicated systems. With a DC microgrid, you manage voltage. And with the simpler system, it made it possible for us to design a completely modular plug-and-play system using third-party components. So for the most part, if you want to put a DC microgrid in to host solar storage and EV charging, there's almost no customization required. There's no site-specific engineering. So those are the primary benefits that we see from DC microgrids.
I'd love to just jump in and reinforce, something that Peter has said a couple of times now, but it's subtle, but it's super important, and it's around the interconnection, the impact to the grid, or even if you're behind the meter, the way that the utilities are doing the interconnections, it's all based on the power capacity of what you're interconnecting. So if you take solar and storage and you DC couple those, which means that they're going to share a single inverter, then the impact that's going to be considered for that DC coupled, solar plus storage system is just going to be the power capacity of that inverter. If you separate them, so you have 100 kilowatt inverter for the solar, for 100 kilowatts of solar, and you have a similar sized inverter for the energy storage, you now have a 200 kilowatt impact, double the impact to from an interconnection standpoint. And the utilities, the utilities use this grid impact as a gating item, right? To kill a bunch of projects, or to make them, squeeze them down so that they can't be, fulfill their greatest potential. And in reality, if you DC couple the solar and the storage, or the renewables and the storage, you basically are providing dispatchable solar, which means it's going to be a lot more valuable to the grid, because it's going to be delivered in times where it's going to actually have the greatest value to the grid. So we have a lot of policies that need to get fixed to encourage the type of work that Peter is doing around DC microgrids. And Sharmila, I know you have a lot of experience in that, because you used to work for Bosch, and I think Bosch is kind of the first big player in the in North America that was bringing that DC microgrids to play. But anyway, I just wanted to just emphasize the importance of DC coupling, at least with respect to the renewables and the storage, because it makes it a lot easier to get those things interconnected. But I will say that it's very hard to find vendors that have DC coupled solutions. So the market, the technological, there's some technology catch up that needs to happen. AC coupled solutions are way more prevalent. But we need to get DC coupled solutions, to basically be on equal footing, so you can actually select that as the preferable approach.
And we think that one of the reasons that we're well positioned to do that is because of our modular approach. So when you go out and look at AC coupling, I mean, it's generally customized. And one of the things I did earlier in my career is help a company that participated in digitization of video. And it was a similar thing there. It was very customized at the beginning of that industry 20 years ago. And we introduced solutions that allowed you to, that made it a commodity. And so what we're trying to do in the DC world is provide that same level of commoditization that allows you to go out and buy third-party hardware that you're used to purchasing and pull it together in a system that'll function as a microgrid. And I certainly can attest as a solar developer to what you had said before. The sort of the worst thing that we did as a solar developer was to put a lot of resources into a particular project and then go out and find out that it was either impossible to connect or it was so costly that it ruined the economics. And so undoubtedly microgrid developers will have the same will face the same situation. And by building it as a DC microgrid and incorporating our type of modular solution, that's at least one thing, one challenge that a developer can remove from the many challenges that they face in implementing these systems.
Thank you, Peter.
So
we have a lot. Sorry, Steve.
I was just going to say these are really excellent points. The perspective that I see this through, though, is more from a financeability perspective, and everything that Peter and Craig was saying, just in and around, bankable technology, repeatability, things of that nature, is key to the rapid deployment and decarbonization in this space. We have a number of DC coupled projects in Massachusetts as part of that SMART program.
Right. And
putting that together was a learning curve from everybody's perspective. And I think, Craig, you hit it right on the head. But you get them done, and then they're easy to finance. Second go around. So it's a key aspect for sure. Peter, you hit it as well.
Right. Great. Very lively conversation here. And we have quite a few questions from the audience, so I would like to get to that. So Jerry, I would like to start with you on this. And actually, this is a question for the entire panel. So one of the questions is, what potential cybersecurity concerns are being pointed out, if any, for on-grid microgrid systems? And a related question part of is, what financing opportunities are there for people looking to construct a commercial scale or residential scale microgrids? So Jerry, could you address, let's start off with the cybersecurity concerns. Electra, being a utility, I'm sure looks at this as a big challenge. How do you address cybersecurity concerns with distributed energy assets?
This is it's probably going to take an hour on discussing this question. Sorry. Well, great question though, but I think that's a very hit on. Yeah, it's something that Electra have been trying to look at a strategy and going forward. How can we addressing cybersecurity issue? But today, I'm not saying we don't have it, but it hasn't been an issue today. But it's definitely something that we're looking at as part of our Grid 2.0 strategy to addressing, the DERs, the risk, the benefit and risk, the risk associated with DERs, including the cybersecurity risk as well. So, yeah, something is on our radar, I would say, but we're not there yet. That's all I can say for sure. And you have a second question about financing, I think.
Yes, financing opportunities for commercial scale and residential scale microgrids. Right.
So commercial scale, there's other financial opportunity down in the market as well. But residential, I can comment on that because we have pilot on residential, solars and battery storage. We're utility definitely putting our own money as well, supporting those pilots, but also looking for the government funding. You have IESO, OEB joint target call, those funding you can target to. You have NRCan resource, Natural Resource Canada funding as well. So there are various local municipality initiatives that you may be able to tap into for funding sources. Yeah, definitely. I think the key thing is just really to get ahead of curve and reaching out to multiple stakeholders in the industry and getting those financial support. On-bill financing is another way to do it in the future, but provide that the policy have to allow us to do so.
Great, thank you, Jerry. Craig,
Well,
yes.
Sorry, I just want to add a little bit to the cybersecurity. I'm not a cybersecurity expert, but this is just kind of commonsensical. You know, when you're talking about microgrids, you're not going to be the same level of target as if you're, you know, an entire utility. Most of the actors that are trying to take over an energy system are going for really massive impact, like, you know, the gasoline pipeline that got shut down, you know, several months ago in the southeastern United States, right? That took out a whole bunch of you know, economic activity out of the Northeast, right? Because the energy was the gasoline was being pumped from the southeast to the Northeast. So that wasn't showing up in the Northeast and had some really big economic impacts up there. If you're a microgrid, you know, for a building or even a university campus or you know, a community microgrid that's a part of a town or city, you're not going to have the same appeal to a bad actor that's trying to take over a grid system. So what I'm saying is that cybersecurity is important for everybody, but your risk, the amount of risk that you are at when you you know, when you have microgrids and you have a whole bunch of them, and nobody's going to want to go penetrate a whole bunch of disparate microgrids, right? That would take a lot of extra. You're like, the amount of effort you have to go into take over all of Electra times, you know, 50, 100, 1,000, 1 million, right? It's just so much work to get individually into each one of those. So I just want to say that by going distributed, which microgrids do by definition, you are inherently a lot safer because you're not going to be the same level of a target.
Thank you, Steve. Thank you, Craig. Steve or Peter, any comments on cybersecurity?
Well, sure. We have considered that. And one of the other unique advantages of our particular type of DC microgrid is that the core functionality for balancing power and energy and safety does not require wired or wireless communications. So by definition, we're much less susceptible to that kind of issue. Obviously, if we're working on optimizing the use of energy, then we need external data. So we need pricing information and weather forecasts and so forth. And then it's really a question for the user, the consumer of this, to decide how they want to balance the efficiency of the system with cybersecurity concerns and how you want to access that information from the outside world. But even if we're hacked, it doesn't upset the fundamental control of the microgrid, the balancing of energy and power, and the safety of the system.
So, Steve, I would like to address the next question to you, which was, what demand have you seen from the commercial sector for microgrids or renewable energy technologies for the purpose of decarbonization?
Yeah, that's a great question. We've seen, you know, massive interest from the C&I space. I don't think that's a shock or surprise to anybody. I think there's a number of sort of dimensions around that. There's a significant amount of organizations, as we've seen, are now making the pledge, pledging to, you know, some targets for decarbonization or net zero, whatever that looks like, you know, renewable energy, without a view necessarily, a notional view, but not a specific path to get there or how to finance it. So we're seeing a massive amount of interest there, without question. You know, I think when we think about solutions, in our view, you know, our approach is really one of a holistic, integrated, and oftentimes phased approach. You know, typically, it's difficult to get there in one can, but it's difficult to get there, and there's not that much appetite to get there sort of in one foul swoop or one strategy. So it's more of a, in our view, it's a bit of a phased approach in the C&I space specifically. So, you know, typically what that looks like is, you know, maybe begin with what we call asset light approach, which is more of the optimization layer, the digital layer, the grid edge layer, and then move to, and that will certainly get you, you know, down the road as far as optimizing spend, your cost rather, and, you know, what decarbonization you can get out of the flexibility of the building. then, our view is in order to supercharge that grid, microgrid, that environment, you move towards more of an asset heavy approach. And that is, you'd add generation potentially, you'd add storage, you'd add EV charging infrastructure. And that really, supercharges that entire environment. So you're really doing three things. You're providing more, we talked about the benefits, resilience, certainly lower cost, decarbonization, but you're also looking at ways to monetize, and this goes back to regs that we haven't really talked too much about, but how do you monetize that flexibility? So that's traditionally have been our approach to that space.
Great. The next question that came through the audience is for Craig. What regulatory incentives, policies have enabled the emergence of business models that allow for securing supply for tier 1 loads, but done in a financially sustainable way? Craig, I guess this is related to the way that you define microgrids. So would love to get your perspective on this.
Sure. The answer is that the policies and market mechanisms are really way behind where the technology is. And this is, despite the fact that I talked about that DC coupling is still behind the curve, there is still AC coupling that's readily available and getting deployed all over the place. And, that's predominantly what's getting deployed out there at the moment, but it should shift over to DC coupling as soon as possible. The policies and market mechanisms are really deficient, and resilience is not being valued in the policies and market mechanisms. There's a lot of discussion around it. It's like, oh, we need to keep people's electricity on, but then when it comes to actually, policymakers putting market mechanisms in place that will ultimately reward the amps and the ARDA powers, and for that matter, Electra and the utilities for providing these enhanced services. And hopefully these microgrids are renewables driven, because when you get renewables driven, you optimize the trifecta of economic, environmental, and resilience benefits. But there has to be rewards there. There are real costs to making sure that you have a microgrid configured to provide resilience, and that comes in the form of making sure you have sufficient levels of generation, you have sufficient levels of energy storage, and you have all the microgrid controls, what the Clean Coalition refers to as the monitoring, communication, and controls, right? And I think that's what ARDA Power does, right? So I'm really pleased with kind of Peter's introduction and all the things that his group is working on. At the end of the day, the heart of it is the monitoring, communication, and controls, right? Solar, it's either producing or it's not. Wind is either producing or it's not. And batteries are either charging, sitting idle, or discharging, right? I mean, the rest of it is all the controls and making sure that, your energy supply is matching up with your energy demand, and you're turning off your tier 3 loads and your tier 2 loads when you need to preserve coverage for those tier 1 loads that should never, ever turn off. So I think I'm going a little off script here. I'll try to bring it. Sharmila, can you just remind me what I was supposed to be talking about?
So yes, sure. The question was what regulatory incentives or policies have enabled the emergence of business models that allow for securing supply for tier 1?
Steve mentioned that he's been working in Massachusetts under the SMART program, and I think that there's probably some really good policies that policies and market mechanisms that are packaged up in that. I'm not very familiar with the SMART program, so Steve, hopefully can share some, shed some light on that for all of us. But in California, where I am most familiar with where the policies and market mechanisms are, we've got a long way to go, and the utilities are very, very reluctant they're slow rolling everything. There is a little bit of hope. Right now in California, there is the very first community microgrid project that is going to get deployed. I'm on the technical advisory committee of it. It's called the Redwood Coast Airport Microgrid. RCAM is the acronym form, RCAM, Redwood Coast Airport Microgrid. It's a feeder segment, has 20 customers, has a municipal airport, and it has a Coast Guard facility. So there's 2 critical community facilities that are part of the 20 customers on this feeder segment. There's a grid isolation. It's the end of a feeder segment, so you only need one grid isolation switch. When the broader grid goes down, you isolate, right? Which means no energy can flow past that grid isolation switch. And you have solar and storage that's going to basically balance the energy amongst these 20 customers. Out of those 20 customers, there's only 2 critical community facilities. The other 18 get a free ride. They're going to get the same level of resilience as the critical community facilities, which is not the way it should work, right? The folks that are not providing, benefits to everybody, they're not critical community facilities that serve everyone. Those guys should pay more to get this level of benefit. Not that they have to pay a whole lot more, but they should have a market mechanism like the resilient energy subscription that I talked about earlier that the Clean Coalition is promoting as a market mechanism to finance community microgrids, to extend them beyond just critical community facilities. There is, just to kind of wrap up this answer, there is some hope. So out of this RCAM project, there is and that's in Pacific Gas and Electric Territory, PG&E. There is a program that is based on that, called the Community Microgrid Enablement Program, or CMEP. That is supposed to, be used for additional projects in the future. So far, it hasn't been used for any additional projects, but it's been talked about, right? A lot of talk, not so much action. And there is an additional microgrid program that's being shaped. A lot of talk, not a lot of action yet, for the other utilities like Southern California Edison and San Diego Gas and Electric, SDG&E. That program is called the Microgrid Incentive Program, or MIP. And there was a meeting yesterday at the California Public Utilities Commission about, some kind of rate considerations for how do we structure a fee or a tariff or whatever that kind of makes that can monetize those microgrids. And it's a very active proceeding, by the way. There's a microgrid proceeding at the California Public Utilities Commission. So far, most of the decisions have been very unfavorable to everything that people in this conversation want to see. But there's hope, right? At least the conversation is happening. And that microgrid proceeding in California is the ones that's really the key. So people want to get involved in that aren't already and need information about it. I'm happy to provide links and whatever so people can get registered and become parties to that action if they're interested.
Thank you, Craig. I guess lots more questions that we could go on for hours, but since we need to wrap up here, I would just like to say thank you to all the panelists. This was a great conversation. I know microgrids definitely hold the key to a lot of challenges that we have with the grid currently, but definitely there is a lot of collaboration that's required across all the stakeholders, not just the traditional players, but also, as Steve pointed out, there is interest from owners and building operators themselves. But I think hopefully in the near future, we can move from just interest to actual deals being done and business models being developed. With that, I would like to hand this over to Julia.
Thank you so much, Sharmila, and thank you to all our panelists today. I guess in terms of closing remarks with 1 minute to go, thank you everyone for joining us. A recording and a recorded version of this webinar will be made available, so we'll just email it out to everyone who's registered, and if you'd like to share it with others within your network, we'd really appreciate that as well. If you are frequently engaging with our events, if you align with our values and have an active interest in building up your professional network in the Proptech ecosystem, we encourage you to join as an official member as well. We have free or paid memberships. So here's the link. Just feel free to connect with us. And yeah, this is our last event for 2021. So I wanted to wish everyone a productive end to the year, and may the new year continue to bring you health, wealth, and happiness. So see you guys, everyone, at our next event in January. Thanks so much.
Thank you.
Thank you.
Thank you.